Alright, so hi guys. So in this video, what I want to do, and first of all, I do apologize for lack of uploads. I think the last time I uploaded was either yesterday or the day before. We're gonna go ahead and do the following problem. And this video is about, for Cal 2, if you're in Cal 2 and you're doing, basically trigonometric integrals, and finding the indefinite integral using trig identities. So it says evaluate the indefinite integral using trig identities and u-substitution. So basically when I was doing this problem, it did not give me that hint, so we kind of had to figure it out. So the first thing here, and I'm going to go ahead and rewrite the problem. Give me 1 second. All right. So the first step that we need to do here, we need to split this into two different integrals, with two different integrands. And so what we're going to do, and this is going to actually equal the following. So step 1 would be to split into two separate, oops, it's the wrong two, into two separate integrals. Okay. So what we're going to do is we're going to go ahead and do the integral of 5 over cosine squared theta. Let me just go ahead and you don't have to put theta in parentheses. I don't usually do that unless it's like, unless it's like 2 theta or something different like that. Sometimes I do, sometimes I don't. If it helps, you can do that. I'll try to do it. I'll try to put parentheses for this video. So, but I don't usually do that because I have a habit of writing it without the parentheses. Okay, so we have this, and then plus 6 sine cubed of theta over cosine squared theta, right? And so the other thing is we're going to split it up even more. So we're going to go ahead and say that this is 5 over cosine squared theta d theta plus the integral, so the integral of 5 over cosine squared theta d theta plus the integral of 6 sine cubed of theta over cosine squared theta d theta. Okay. So now if we use trigonometric identities, we can actually split this up into, so this first part here that we have right here, we know that we can use trig identities. Basically, anything that the trig identity 1 over cosine squared theta is known as secant squared theta. Since we have a 5 there, I'm going to take the 5 and I'm going to put it outside. So 5 integral of 1 over cosine squared theta d theta, and then plus, and then I'm going to do the same thing for this part here. So we have 6 integral sine, and actually this is supposed to be, sorry, my handwriting is just not readable. Okay, so sine cubed of theta over cosine squared theta. Okay, so we're putting this here, and so again we're going to put d theta like this, right? And so now let's go ahead and we know that again this is secant squared theta right here. So we're going to go ahead and put that in. So we have 5 integral secant squared theta, again, that's the trig identity for that, plus 6 integral, and we're going to split this up. So the way that this is going to go, we're going to split this up into sine squared theta times sine theta. And again, let me do that. Over cosine squared theta. Okay, so this is going to actually be, we're going to go ahead and use the trig identity that basically from the Pythagorean identity, we can go ahead and simplify the sine squared theta as, if y'all remember, 1 minus cosine squared theta. So we really have to know our trig identities for this. I do have videos over trig identities if you guys are not familiar with those. I would look them up if you don't know them. Okay, so we know that the integral of secant squared theta, that is actually a common trigonometric integral. This is going to be equal to tan of theta, so tan theta, basically. So we know that this entire integral here, this entire integral is actually going to be, we're going to actually put that as 5 times tan of theta. And so that gets rid of that, right? We know that this is what this is right here. So this whole thing becomes this. And so then we have plus 6. And like I said, we're going to put, in place of the sine squared theta, we're going to put this here, 1 minus cosine squared theta. So we're going to have the integral. And we're going to actually do sine of theta times 1 minus cosine squared theta over cosine squared theta d theta. Okay, so from here, let's erase this here. We're going to go ahead and again split this up. So what this becomes is the following. We're going to do 5 tan theta plus 6 integral, and we're going to do the following. It's going to be, 1 second, guys, hold on. We're going to put, basically, we're going to put this separately. So we're going to first do the following. We're going to go ahead and put times sine of theta, which is that, right? Integral of sine of theta. And then we're going to just multiply this to 1 minus cosine squared theta. Again, let me just make sure. Over cosine squared theta. Okay, guys. d theta. Alright, so now we're going to use what is called u-substitution. If I make u, so let's go ahead and we can use u-substitution to substitute u equals cosine theta for this, okay? So we're going to put u is equal to cosine theta. And the reason why we're doing that is because if we do that, eventually the sine theta will cancel out. So if we find du, this will actually be the derivative of u, which is negative sine theta, d theta. Okay, so we're going to get the following. And again, the 5 tan theta just stays like that, plus 6, and we're going to do the integral of sine theta, and then times, we're going to again substitute u for cosine theta, yes. So we're going to do 1 minus u squared, so u squared here, over u squared. And then again, du, so if I actually solve this for d theta, which would be the, like this part here, I know that the way that I do that is by dividing by negative sine of theta on both sides. So we have to do that in order to solve for d theta. So d theta is du over negative sine theta. And as you can see when we do that, we know that that's going to go in place for this. So it's going to be, we're going to close this here and we're going to put du over negative sine of theta. Now, as I said, the sine of theta will cancel out. So we're going to cancel this out, but be careful. This is over negative 1. I really want to emphasize that because I do not, we have to be careful. It would be du, so it would actually be, again, let me rewrite it. So it would be like this, right? Because again, it was negative sine theta. The sine theta went away, but we're still left with a negative at the bottom. So we need to take that into consideration. Because this is negative 1, we can do the following. We know that this would be plus 6 integral of, we can split it up, 1 over negative 1 times 1 minus u squared over u squared times du. So we know that this is actually a constant, so we can take that out. So we have 5 tan of theta plus 6 times negative 1 integral of 1 minus u squared over u squared du. Okay, and now this becomes 5 tan of theta minus 6 integral of 1 minus u squared over u squared du. So our only last step here, guys, is to just integrate 1 minus u squared over u squared. And if you think about it, we can actually just use power rule for integration. So we have 5 tan theta minus, it's going to be minus 6 integral, and again, we're going to split it up, 1 over u squared. So this is what this whole thing here, 1 over u squared, and then it's going to be minus u squared over u squared. Because again, that's kind of what this is. We split it up into 2 fractions, right? Du, this whole thing with respect to u. And so if you see it, if you think about it, this becomes 5 tan of theta. So again, the 5 tan theta just stays the same, minus 6, and we're going to do the integral of 1 over u squared du minus the integral, and u squared over u squared just becomes 1 du. So basically, this is going to become the following. And by the way, again, this whole thing is multiplied by 6. We want to make sure we make that very clear, because again, I almost forgot to put that in there. This 6 is being multiplied to all of this. So we have 5 tan of theta minus 6, and the integral of 1 over u squared du Well, if you think about it, the derivative of 1 over u is negative 1 over u squared. If we do the derivative of negative 1 over u, I mean, if you just do power rule here, it's going to be u to the negative 1, or negative u to the negative 1. It's going to be negative 1 times negative u to the negative 1 minus 1. This is going to be u to the negative 2, which is really 1 over u squared. So we know that the integral of 1 over u squared will be negative 1 over u. So we're going to put that in here. And then minus, and again, this entire thing is going to be minus, and then the integral of 1 du is just u, because it's a constant. So then from here, all we have to do is distribute and then substitute u back in. So we're going to have 5 tan theta plus 6 over u, and then plus 6u. Now, if you want to go ahead and we're now going to substitute u back in, and this is, we always have to make sure to add the constant of integration. So now the last step, and last 2 steps actually, are going to be the following. We're going to substitute u back in. So in our problem, we said that u was cosine theta. So now we're going to substitute it back in. We're going to have 5 tan of theta plus 6 over cosine of theta plus 6 cosine of theta plus the constant of integration c. The last step is to use trigonometric identities here. So we're going to do 5 tan of theta plus 6 secant of theta, because as I said before, 1 over cosine theta is secant theta. And then plus 6 cosine of theta plus the constant of integration c. This, guys, is going to be our final answer for this problem. So that is going to be it for this video. I do apologize if it was lengthy. This was a very lengthy problem. But with that being said, if anybody has any questions, please let me know. And also, please like, comment, and or subscribe. And I will see you guys in the next video. And thank you so much for watching. Bye, guys.